So let's look at a better implementation of sequential consistency in which a core can reorder loads, but this can lead to violations of sequential consistency. So it has to also detect when sequential consistency may be violated and fix things. This is of course easy to say, but how do we really do that? So let's look at a program where there is a load to A, and then sometime later, but not too much later, a load from B. So we need to make these execute in order. If doing otherwise will violate sequential consistency, but we want to really execute them out of order if there is no potential for sequential consistency violation. So let's look at what happens in the reorder buffer of a processor that tries to execute this. The reorder buffer keeps instructions in program order, so the first load will be known to come ahead of the second load. Now, if we actually do this access first and this second, then there is no potential for violating sequential consistency because we are actually doing whatever the simple implementation would do anyway. So the sequential consistency violation can occur when we first do load B in a real execution order, and later, for example, because the computation for address of A has been delayed, we do load of A. Now, the important thing to note is that this is not necessarily a violation of sequential consistency. If nobody writes either B or A during this time, then the B here and the A here will be the same as if we reorder them back to their original program order. So we are getting the same value of B no matter where we load it if nobody writes anything. In fact, for this to actually be a violation of sequential consistency, like we can actually get a different value for B than we could in sequential consistency, what has to happen is that there is at least one store to B between the time we actually read B and the time when we should have read B according to sequential consistency. Why? Well, because if we don't have the store here, then the value we read here is the same as the value that we would have read here where it would be okay to read B. So now you can see how we can detect violations of sequential consistency. When we read something ahead of program order, we need to start monitoring the coherence traffic produced by other processors. So if we see such a store, then this load and anything that it fed the data to must be replayed. Note that this load is replayable because in the ROB it's here. We are assuming that this load still hasn't happened, which means that the commit pointer for the ROB is somewhere here or maybe at the load here, but definitely the load from B has not been committed, so we are capable of replaying it. In the worst case, we can just cancel this load and anything that follows and just refetch those instructions. So we know how to undo the damage here, but in order to detect the violation, now we have to basically anything that we load out of order, we need to monitor coherence traffic until that load becomes in order.